Hi, welcome to Nomis Academy. In this video, I'll be solving some problems on product and quotient rule with trigonometry. So, find the derivative of y if y is equals to x cubed cos x. So, we are going to see how product rule and quotient rule can be used to find the derivative of trigonometric identities. So like this one. So we're going to take them one after the other to see which of this rule is applicable to the question we are solving. So look at question number 1. Roman figure 1 says y is equals to x raised to the power of 3 multiplied by cos x. Correct. That is the product rule. So let's use this product rule to solve question Roman figure 1. So the question from there transit to be x raised to the power of 3 multiplied by cos x raised to the power of cos x. So the solution says that it follows product rule and therefore we must reduce the product formula. What does the product formula says? It says the y dx is equal to u dv dx plus v du dx. So we need to find out some of these parameters. We already know the u, we already know the v. What is the u, what is the v? So let's point them out. Then the v dx, the u dx, let's point it out, then put them back into the formula. So our u is x raised to the power of 3. That's good. Then our v is cos x. Okay, what about the v dx? The v dx is to differentiate v. When you differentiate cos x, can you remember what you will get? Correct. Minus sine x. Now, we need du dx. du dx. So what about du dx? Du dx, just use the simple formula 3 multiply x raised to the power of 3. Where did I get this 3? Remember, it is this superscript, this 3, that I brought to multiply everything here by subtracting 1 from that same 3. So 3 minus 1. So that gives 3x raised to the power of 2. So this is the u dx. Now, let's put them back into the original formula. That is to say that the y dx is equal to u. What is our u? Remember, the u is x raised to the power of 3. So x raised to the power of 3 to multiply. What about the v dx? That is when we differentiate v minus sine x. So this is minus sine x. Now plus, which is the normal plus that is in the formula, v. Now this v is what? Cos x. So we're going to put it there, cos x. And then what about the u dx? If you differentiate the u dx, that's 3x squared. So we have 3x squared there multiplying 3x squared. So finally our answer, the y dx, is equals to minus sine x multiplied by x raised to the power of 3. So multiply by x raised to the power of 3 plus the same thing here, 3x squared multiplied by cos So now let's begin to find out these parameters from the question given to us. What's our v? Remember, the v is the denominator, so the v is cos x. So we're going to put it cos x. What's our u? Our u is sine x. Sine x. Then what about du dx? Du dx, that is when we differentiate sine x, what do we have? When you differentiate sine x, you will have cos x. Good. Then what about dv dx? Dv dx. When you differentiate v is cos x. So when you differentiate cos x, you have minus sine x. Minus sine x. Then what else do we need? V squared. So what's the v squared? Remember, v squared is just cos x squared. So these are the parameters that we need in the formula given. I mean the quotient rule formula. So let's put in all these parameters into the formula and then simplify. The y dx is equal to v cos x multiplying du dx. Du dx is another cos x minus, what's our u? U is sine x multiplying dv dx. Dv dx is minus sine x, so multiplying minus sine x all over v squared. All over v squared. And what's the value of v squared? Cos x squared. So cos x squared. So to simplify this, we now have cos x multiplied by cos x, that's cos x squared. Cos x squared minus sine x multiplied by minus sine x. That will definitely give us plus sine x squared. Remember, minus times minus gives us plus. So minus sine x multiplied by minus sine x.